We're using Scikit-learn's GroupShuffleSplit for a special kind of cross-validation. It's designed for situations where your data is grouped, and you need to ensure that samples within the same group always end up in the same fold during cross-validation. Think of it as a way to keep related samples together. Break time 300 milliseconds. I have 100 data points, organized into 20 groups of 5 samples each. I want to divide this data into 5 separate folds for cross-validation. Making sure that groups remain intact. Break time 300 milliseconds. This statement suggests that each fold will have precisely 20 samples. However, because of the group constraint, I can't guarantee this. I need to make sure that entire groups stay together. Break time 300 milliseconds. This is actually what GroupShuffleSplit does. I guarantee that the entire group of samples will be in one fold. No splitting groups. Break time 300 milliseconds. Because each group will be in only one fold as stated above. This follows automatically. Break time 300 milliseconds. Since I have 100 samples and 5 folds, you'd expect about 20 samples per fold 100520. But, because I must keep groups together, some folds may have slightly more or fewer samples than 20. Break time 300 milliseconds. This helps visualize the dataset. I have many groups, each with 5 samples. We can imagine this dataset as boxes, where each box group has 5 items inside. I am trying to divide the boxes into 5 sets for my experiment, making sure that none of the boxes are split. Break time 300 milliseconds. I am looking at a dataset with 100 samples. These samples are cleverly grouped into 20 groups, with 5 samples per group. This grouping is important because it influences how I split my data for cross-validation. I am using a special tool called Say As Interpret AS Characters GroupShuffleSplit Say As from Scikit-learn to do stratified k-fold cross-validation. Break time 300 ms. That's a fancy way of saying I am dividing my data into multiple folds for testing in training. Break time 300 ms while making sure that samples from the same group are always together. Because I have 100 samples and I want to make 5 folds. If I divide perfectly, each fold gets 20 samples 100520. Break time 300 ms. But Google style name excited. Remember Google style. Break time 300 ms. My samples are in groups. Break time 300 milliseconds to keep groups intact. Some folds might have slightly more or fewer samples than 20, but it will always be a multiple of 5. The magic of Say As Interpret AS Characters GroupShuffleSplit Say As is that it keeps all samples from the same group together in the same fold. It doesn't split them up. Break time 300 milliseconds. This is a key feature. Google style name emphatic. It's guaranteed. Google style break time 300 milliseconds. Google style name lively. This is awesome. Google style. This statement is directly related to the previous one b. Because Say As Interpret AS Characters GroupShuffleSplit Say As keeps groups whole. It's impossible for a single group to appear in more than one fold. It's a direct consequence of point b. If I ignore the group structure, then yes, each fold would have exactly 20 samples. However, because of the group constraint, I can't guarantee this. Some folds might have more or fewer samples to keep groups together. Google style name excited SO. This is wrong. Google style. I have 100 data points, neatly organized into 20 groups. Each group contains exactly 5 data points. This is the structure I am working with. Break time 200 milliseconds. I am using a special technique called Say As Interpret AS Characters GroupShuffleSplit Say As from Scikit-learn. Break time 200 ms. This clever method helps me split my data into 5 different folds for cross-validation. The crucial part is that it keeps all the data points within each group together in one fold. Break time 200 milliseconds. I am performing say is interpret as characters k say is fold cross-validation. But with an important twist. Break time 200 ms because of the grouping in my data. I use say is interpret as characters group shuffle split say is to ensure that the groups stay together. During the splitting process, break time 200 milliseconds. This method is a stratified version of say is interpret as characters k say is fold cross-validation, which means it tries to keep similar proportions of each group across folds. Break time 300 milliseconds. My goal is to divide the data into 5 separate folds for evaluation. Break time 200 milliseconds. This is the standard say is interpret as characters k say as in say as. Interpret as characters k say is fold cross-validation. Break time 200 milliseconds. Because I am prioritizing keeping groups together. Each fold will have roughly 20 data points, 100 total samples divided by 5 folds. Break time 200 milliseconds. However, the exact number of samples in each fold might vary slightly because of the group constraint. I might have a few folds with 20 data points, and another with more or fewer. Break time 300 milliseconds. I am using say is interpret as characters group shuffle split say as for cross-validation. It's a special technique in scikit-learn that's perfect when you have data grouped in a way that we can't split across different folds. Think of it like making sure all the members of a team stay together in a game, not split up across multiple teams. Break time 300 milliseconds. The key here is that say is interpret as characters group shuffle split say is keeps samples from the same group together in the same fold. That's the golden rule. Break time 300 milliseconds. I guarantee that if I have data grouped like repeated measurements on the same subject, say is interpret as characters group shuffle split say is prevents splitting those groups between training and testing sets in a cross-validation process. This makes the results more reliable and avoids biased evaluation. Break time 300 milliseconds. We have 100 samples, neatly organized into 20 groups with 5 samples per group. I want to split this data into 5 folds for cross-validation using say as interpret as characters group shuffle split say as. Break time 300 milliseconds. I need to figure out which statements about the resulting folds are definitely true based on how say is interpret as characters group shuffle split say is works. Break time 300 milliseconds. This is false because say is interpret as characters group shuffle split say is prioritizes keeping groups whole. Since group sizes are 5 and the folds may not be exactly 20 samples. Break time 300 milliseconds. This is absolutely true. That's the main point of say is interpret as characters group shuffle split say is no group gets split. Break time 300 milliseconds. This is also true. It directly follows from statement B. Say is interpret as characters group shuffle split say is enforces this. Break time 300 milliseconds. This is true, because groups must stay whole. Well, get approximately 20 samples per fold, 100 samples 5 folds 20. But it might not be exactly 20 due to the constraints of group integrity. Break time 300 milliseconds. I am using scikit-learn say is interpret as characters group shuffle split say as for cross-validation. It's a special technique I use to handle data where samples are grouped. And I don't want to accidentally split up the groups during my analysis. Think of it like making sure all the members of a team stay together throughout a tournament. I have 100 individual data points, neatly organized into 20 groups of 5 data points each. I plan to split my data into 5 separate sets folds for cross-validation. This helps ensure the reliability of my model by testing it on multiple subsets of the data. The goal here is to figure out what is guaranteed to be true given the way I am splitting the data. Considering that I am using the say as interpret as characters group shuffle split say as method and have set a random state for consistent results. This is a core feature of the say as interpret as characters group shuffle split say as technique. Each of my 20 groups stays completely within one fold. No group members will be separated. Google style name excited. That's a key guarantee. Google style. This statement directly follows from statement B. Since each group remains whole, it's automatically true that no group will be split between different folds. Because I want to keep my groups whole, and I have 20 groups, each of the 5 folds will have approximately 20 samples. The number might vary slightly because I have to make sure groups stay together. I am using GroupShuffleSplit, a scikit-learn function. Break time 300 milliseconds. It's perfect for cross-validation when say is interpret as characters as have groups of samples that say is interpret as characters is shouldn't split across different folds. Break time 300 milliseconds. Think of it like keeping related items together. Break time 300 milliseconds. For example, if say is interpret as characters is testing different medicines on patients. Say is interpret as characters would want to keep all measurements from the same patient in the same fold to avoid bias. Imagine say is interpret as characters as have 100 data points, neatly organized into 20 groups with 5 points in each group. Say is interpret as characters want to split these 100 samples into 5 separate subsets, called folds, for cross-validation. This is false. Break time 300 ms because GroupShuffleSplit keeps groups together. It's unlikely that each fold will have exactly 20 samples. Break time 300 ms. The number of samples per fold will be a multiple of 5 the group size. This is true. That's GroupShuffleSplit's superpower. Break time 300 milliseconds. It guarantees that all data points within a group will land in the same fold. Another true statement. Break time 300 milliseconds. This is a direct consequence of keeping groups whole. This is also true. Break time 300 ms. While the ideal is 20 samples per fold, 100 samples 5 folds. The actual distribution might vary slightly because GroupShuffleSplit prioritizes group integrity. I am using scikit-learn's say as interpret as characters GroupShuffleSplit say as for cross-validation. This special tool is designed to handle datasets where samples are grouped, like repeated measurements on the same person. It ensures that samples from the same group always end up in the same fold during cross-validation, preventing data leakage. I have a dataset with 100 samples, neatly organized into 20 groups. Importantly, each group contains exactly 5 samples. This grouping is crucial because I don't want to accidentally mix samples from the same group during my cross-validation process. I want to split my data into 5 folds for cross-validation, which is a technique to evaluate a machine learning model's performance reliably. The question asks me to identify which statements are definitely true about the way say as interpret as characters GroupShuffleSplit say as divides my data given the groupings and the number of folds. This statement says each fold will have exactly 20 samples, 100 samples 5 folds, 20 samples fold. However, Since say is interpret as characters group shuffle split say is keeps groups together. This might not be true. The number of samples per fold will be influenced by how many whole groups fit in each fold. This is the core idea behind say is interpret as characters group shuffle split say as. It guarantees that all samples from the same group will always end up in the same fold. This directly follows from statement B. If each group is entirely in one fold, then no group can be split across multiple folds. Because say is interpret as characters group shuffle split say is prioritizes keeping groups whole. The number of samples per fold might vary slightly from the ideal 20. It will be close to 20, but not necessarily exactly 20. Because of the constraint of keeping groups intact.